Okay, in this video we're going to look a little bit more closely at the power rule for exponents, and then we're going to look at some examples of using exponent rules to simplify expressions. So first, let's just review the power rule for exponents. Remember, the power rule says if I have something like x squared raised to the third power, so you're raising something that has an exponent to another exponent, then you multiply those exponents together. So x to the 2 times 3 is equal to x to the 6th power. Okay. So now let's look at it when we are taking the exponent of something that's a product or a quotient. So say I am looking at this expression, 2x squared to the 3rd power. So let's just talk for a second about what the exponents are, what exponents belong with which quantities and terms right now. So right now the x is squared, the 2 is not squared. The 2 is just by itself, and then both the 2 and the x squared are being raised to the 3rd power. So we need to look at how we're going to handle this. So one way to think about this is we can expand it out and say, well, it's going to be 2x squared times 2x squared times 2x squared. So 2x squared times itself 3 times. That's what 2x squared cubed means. And then I could rewrite this and kind of start grouping like terms together. I have 2 times 2 times 2, so I have 2 to the 3rd power, and then I have x squared times x squared times x squared, which is like x squared to the 3rd power. And we can use our product rule to tell us that's 2 cubed x to the 6th. So an important thing to notice here, let me change colors so we can see it a little bit better, is that I basically took this exponent and I distributed it to every term inside. So the 2 was cubed and then the x squared was cubed. And that's how you always want to handle products like this. When a product like 2x squared is raised to an exponent, you have to make sure that every term inside of your parentheses gets that exponent. So a similar thing is true when you start looking at quotients. So remember, a quotient is when two things are divided. So let's say I have x cubed over x squared, and all of that is being squared. Okay. So remember, another way we can think about this is we can think about this as x cubed over x squared times x cubed over x squared. Right? And that we can rewrite as x cubed times x squared. X cubed times x cubed. We multiply straight across when you're multiplying fractions. So I get x to the 6th over x to the 4th, which can simplify down to x squared. So let me switch colors again and show you what I did with this one. This is very similar to what we did in the previous example, where we had to, if we wanted to do like a shortcut of this, we would need to take this squared on the outside and distribute it to every term in the top of our fraction and every term in the bottom of our fraction. So we ended up with, change this again, we ended up with x to the 3rd raised to the 2nd power over x squared raised to the 2nd power, which is x to the 6th over x to the 4th. And you see that's the same as what we did when we broke it down even further. So the key with this power rule is that you want to make sure the power on the outside of the parentheses gets distributed to everything inside. Now that we've seen what the power rule does when we're dealing with products and quotients, I want to look at a few, oh man, what just happened there? I wanted to look at a few examples of what it would look like to simplify some exponential expressions. So we'll try to start easy and then kind of build up. So the first example I want to do is if I have 9 to the negative 3rd times 9 to the 8th. Okay. So this one you might be tempted to want to put it into your calculator because you're just dealing with numbers, right? There's no variables. We do not want to use our calculators for this. We want to keep this as an exponential expression. So we are going to do the product rule on this one because we're multiplying two things together. So remember, the product rule tells us that if we multiply two exponential expressions together that have the same base, so the base here is 9, then we just get to add the exponents. So 9 to the negative 3 plus 8, and then we can simplify that exponent to be 9 to the 5th, and that's it. This is actually way faster and way easier than putting it in your calculator. So on top of that you should be able to do this, it's actually a lot faster to just work this out. Okay, next one I want to look at is going to be another product. So 5x to the negative 4th y cubed times x squared y to the negative 1. Okay, so here we've got a few things going on. We have multiplication happening, we have constants like 5, and we have two variables, x and y. On top of that, we have negative exponents and positive exponents. So first what I'm going to do is I am going to combine my like terms. So I see, for example, that I have an x to the negative 4th and I have an x squared. So if I wanted to do the product rule on those, I would add those exponents together and I would get x to the negative 2. So when I multiply those together, I end up with x to the negative 2. With the y's, I have a y to the 3rd power and a y to the negative 1st power. So when I add those exponents, I'm just left with y squared. And then with constants, I only have that 5, so it just gets to stay out front. Now, this expression that I just wrote looks a lot better than what we started with. However, it is not considered simplified yet. So an important part of simplifying exponential expressions is that we want to get rid of all of our negative exponents. So what I've written is not technically incorrect, it's just not in the simplified form that we generally want it in. So I just need to figure out what to do with this x to the negative 2 power that's sitting there, and I need to turn it into a positive exponent. So if you remember correctly, if I want to get rid of that negative, I just basically move it to the bottom of a fraction. And by taking that x squared and putting it on the bottom, I'm getting rid of the negative. I'm rewriting it as a positive number. And this is allowed because we know that x to the negative 2 is equal to 1 over x squared. So what I did is I just replaced the x to the negative 2 up here in my expression with the 1 over x squared so that I could get rid of that negative exponent. So when you're simplifying, make sure you read the instructions because it'll usually tell you to get rid of all the negative exponents. Okay, let's take a look at a quotient. So let's look at 4x cubed y squared over 6x to the 7th y. Now, I generally like to look at these kind of, like here I have numbers, like 4 and 6, and I have x's and I have y's. I like to look at them one at a time. So first, if I just look at my numbers, my 4 and my 6, if I were to simplify that 4 and that 6, I would get 2/3. So on the top of my fraction, I'm going to have a 2, and on the bottom, I'm going to have a 3. Then I have this x to the 3rd and this x to the 7th. So if we think about canceling out like we did before, I have 3 x's on the top, and I have 7 x's on the bottom. 7 x's that are multiplied together. So if I think about canceling things out, I can cancel out 3 x's from both the top and the bottom, which leaves me with no more x's on the top, and then x to the 4th power here on the bottom. So now let's look at our y's. So I have y squared over y. So I have 2 y's being multiplied together on the top and 1 y being multiplied on the bottom. So I can cancel 1 y from the top and the bottom, and I'm just left with 1 y on the top. Okay. I'm going to show you another way to solve this. With exponential expressions, there's usually multiple ways you can think about simplifying it. So I'm going to go ahead and think about another way. I'm going to leave the 4 and the 6 the same. That pretty much is simplified the same way every time it simplifies down to 2/3. You could also think about bringing all of your exponents to the top of your fraction. So if I want to bring, for example, this x to the 7th up to the top of my fraction, I would subtract the exponent. So x to the 3rd power over x to the 7th power would be x to the 3 minus 7, which is x to the negative 4. If I do the same thing with the y's and I subtract the exponents, then I'm left with y to the 1st power. So this is nice. The downside here is that I have a negative exponent. I can easily fix that though by simply bringing the x to the negative 4 and bringing it down to the bottom. So both of these ways are just different ways of simplifying the exponential expression. So whichever way you're most comfortable with is great, but I do want you to understand and be comfortable using both of those. Okay, so we're going to look at one more example that lets us use the product rule. So let's take a look at if I had y squared z to the third all over 5, and that whole entire thing is raised to the negative third power. Okay, there's several ways again that we can go about thinking about this. What I'm going to do is, let me change the color of my pen so you can see what I'm doing. I'm going to take this negative 3 and I'm going to distribute it to every term in the top, so to the y squared and to the z cubed, and to the bottom, so down to the 5. Now let's see what that looks like. Then I end up with y squared to the third power, z cubed to the negative third power, and 5 to the negative third power. Okay, now I can do the product rule on each of these individual little variables and numbers. So if I have y to the negative 2 raised to the negative 3, that leaves me with y to the negative 6. Similarly with the z, we're going to end up with z to the negative 9, and then the 5 is just chilling by itself still, so 5 to the negative 3. Now this looks better than we started with, again, but it looks super bad with our negative exponents, so we got to get rid of those. So here's another way to remember your negative exponents. Basically, if you want to get rid of a negative, take a term and put it on the other side of the fraction. So if I take this 5 to the negative 3 and slide it to the top of my fraction, all of a sudden it became a 5 to the positive 3. If I take the y to the negative 6 and slide it to the bottom of my fraction, it becomes a y to the 6th. And that z becomes a z to the 9th. And this new fraction down here would be our simplified expression. Now, we do know what 5 to the third power is. 5 to the third power is 125. So if you wrote this as 125 over y to the 6th, z to the 9th, that's totally fine. But I also don't want you to feel like you have to multiply out all the exponents. So if this was like 5 to the 13th power, I would want you to just leave it as 5 to the 13th, rather than type in your calculator, what is 5 to the 13th, and get some giant number. So for now, it's totally okay to just leave all of your constants just as exponents, just like that. Another thing as you're working through your homework and your tests and quizzes on this is you really want to make sure you track every step of your work. It's going to make it easier to keep track and to see if you make a mistake, where you made the mistake, and why you made the mistake. So for example, with this, maybe you made a mistake with the power rule and distributing the power, or maybe you made a mistake with the negative exponent. So by showing your work, you're going to be able to find your mistakes and relearn those concepts that you need to.